Have you ever wondered if there was a quicker way to empty out a bottle of water? Well, I've asked two of my brothers if they know the answer to that question. The only condition is they cannot damage the bottle in any way. This means that they cannot squeeze the bottle or pierce a hole in the bottle. The only items that they will have is a bottle filled with water and a straw. Let's see if they know the answer to that question. So the challenge is that you have to try and empty out this 2-litre bottle as fast as possible, but the condition is that you can't squeeze the bottle or damage the bottle in any way. The only thing that is at your disposal is this 2-litre bottle and a straw. What do you think is the best?
The best way is to have an air pocket.
So you're putting the straw in again.
Put the straw in.
Okay.
Closing the top.
Okay.
For some reason.
Okay.
Yeah. And then I'm just tipping it over and then letting go. But I'm not sure what the science is behind it.
Okay. Okay. So that emptied out really quick. Okay. Alright. Okay. What were you trying to do there?
I have no idea.
Okay,
something about air bubbles or something.
So you notice that when you put in the straw,
yeah,
and you open the top of the straw on both ends,
yeah,
the water went out quicker.
I think that's because there's a air gap going all the way through the straw.
So you're saying that there's air that can enter the bottle,
that travels
through the bottle, through the straw into the top of the bottle, and allowing the air to go inside,
flow,
and allowing the water to flow out.
If I just tip it down like that,
okay,
there's no air coming in.
Okay.
Because all the water's coming out.
Here you can see what it looks like if they were just to turn the bottle upside down. As the water leaves the bottle, an area of low pressure is formed. The volume of space that's left behind needs to be replaced by the air from the outside of the bottle. Air is entering the bottle at the same time as the water leaving the bottle. You can notice there is a more consistent flow of water out of the bottle. This is because the air has a dedicated route to enter the bottle via the straw, without being blocked by the flow of water out. That might seem simple enough, but let's do the challenge again without the straw now.
The quickest way...
Remember that you can't squeeze it,
okay,
or damage the bottle in any way.
Okay. Probably stick a finger in or something.
Nope. And what would happen when we do that? Let's see.
Making gaps.
Want to make a gap? Okay. Nope.
Nope.
Okay. So you're trying to put your finger into it?
Yeah.
Okay. And what's that trying to achieve?
I don't know, but it makes sense.
Both of my brothers thought that inserting a finger in the bottle would increase the flow rate of water out. As you can see, this has a negative effect since their fingers are actually blocking the exit and preventing water flowing out. Okay. Okay. So you're trying to pour it out so that the top of the bottle has access to the air.
Yeah. And they push it down.
Yeah. And at the same time, the bottom half of the lid is emptying out with water. Although the flow of water out is more consistent, because the bottle of water is not turned fully upside down, the flow rate of water is still quite low. This means it still takes a long period of time for the bottle to empty.
I think I know what to do.
Okay.
Shake the bottle.
Shake the bottle in what way?
Yeah.
Okay.
Up and down motion.
Although shaking the bottle forces more water out, the water is sloshing up as well as down. So there are periods where water is leaving and then staying in the bottle. Do you think you have any other solutions?
So I think I'm going back the right way.
Okay.
To swirl the bottle around so the water creates a cyclone effect, then you pour it down.
Shake it out. Well done. So what you do, you're correctly turning it upside down. Then you have to make a vortex. Create a vortex in the bottle. You can see how quick the water leaves the bottle. So can you explain why making a vortex in the bottle made the water empty out?
I guess it's got to do with what do you call it? Fluid dynamics. Am I right? High and low pressure. So it basically moves from the high pressure to the low pressure. So when we swirl the bottle around, when we swirl the water, it creates a low pressure at the bottom of the bottle. Okay, and as a result, that low pressure is causing the water to exit the bottle a lot quicker than without swirling it around.
The phenomenon that we are observing does relate to a branch of physics and engineering called fluid dynamics. When you swirl the bottle, you are creating a vortex. The vortex creates a low pressure funnel of air in the middle of the water that allows air to flow from the outside into the inside of the bottle, and at the same time allows water to flow out. You can think of it as being an invisible straw. It took only 8 seconds to empty, although this value does vary depending on how much force is applied when swirling the water. The faster the water swirls around the bottle, the more time it takes for it to lose its energy in order for it to leave the bottom of the bottle. You can see how there's no glugging effect in the bottle. One of the conditions that I specified at the start of the video was that you cannot squeeze or make a hole in the bottle. If you were to do so, creating a hole at the top of the bottle will allow air to enter the bottle in a different route. If you were to squeeze the bottle, you would reduce the volume in the bottle and therefore increase the pressure. As a result, the water would leave the bottle at a greater flow rate. The idea of creating a vortex has been applied in the design of beer taps to allow you to pull the perfect pint.
If you like more of these videos, please like, share and subscribe.
Thank you. Do you have any other solutions?
To swirl the bottle around so the water creates a cyclone effect, then you pour it down. Is that right? Is that right?
Because you read my script.
No.